Hi, and welcome to 1-4, the distributive property. All right, so we're taking notes today on the distributive property. First thing we're going to do is we're going to start with the definition. So our definition is going to be, distributive property. So distributive property, we're going to first look at the math definition. So our math definition is going to be for any number A, B, and C, we have the following. So we have A times the quantity B plus C, and that's going to equal, and we're going to distribute across. So that's A, B plus A, C. So because we have multiplication in between there, we can just say A, B plus A, C. The other way to write this is to have B plus C times A, because we technically have multiplication and that's commutative, so we can have either order. So we're going to then get A or BA plus CA equals, and then the reason why I'm saying equals is to show, well, technically, because we have multiplication in between here, we can have AB plus AC. So notice how these are equivalent to each other. These two are equivalent because order doesn't matter with multiplication, so that's what we get. So similarly, we can have A times the quantity B minus C to get AB minus AC. And we can do B minus C, that quantity, times A to get BA minus CA, which is technically the same thing as AC minus A, or AB minus AC. So again, these two are going to be equivalent of each other. The only difference is we're switching the order of how we are distributing. So we can either distribute on the front end or on the back end. So next, on the next page, we're going to talk about the just the definition when we're talking about the distributive property, and I'm going to abbreviate it like this. The way to think about the distributive property is that it's just multiplication over addition and subtraction. It's that idea that we can have something and distribute it over addition and subtraction. It's only multiplication. We cannot distribute using addition on the outside. So say we had something like 3 plus, and then we had B minus C. We cannot distribute this. Don't do that. That is not a thing. It has to be multiplication. So this is what it would have to look like in order for us to distribute it. Or another option would be, say we had B minus C plus 3. We're not distributing this over this. Don't do that. We would have B minus C 3 here, and then we can distribute it, okay? So it's multiplication over addition and subtraction. That's your basic definition. So let's do a couple examples. The first example, we're going to say use the distributive property and to rewrite the following. If I can spell. So rewrite the following expression and simplify. Okay, so our example is going to be 6 times the quantity 8 plus 10. Yes, I know we can add 8 plus 10, but we are going to use the distributive property to solve this because I don't know what 6 times 18 is without using a calculator, but I can easily figure it out by using the distributive property. So first thing I want to do is I want to distribute my 6 over my 8 and 10. So we're going to use the distributive property. And so we're going to get 6 times 8 plus 6 times 10, and then we're going to multiply. And so we get 6 times 8 to get 48, plus 6 times 10 to get 60, and now we are going to add. And so when we get this, what's going to happen is, well, we know 4 times 6 is 10, and then we have an 8, and so we get 108. All right, let's go to the next page. If it'll cooperate. There we go. Okay, so on the next page, we're going to try a little bit more difficult problem. So we have our next example. We're going to have negative 2 times the quantity 3x squared plus 5x plus 1. All right, so that means I'm taking this whole term, the whole thing that's in front, and I'm distributing it to every single term I have in my parentheses. So first thing we're going to do the distributive property. So that's the first thing we're going to do. So we have negative 2 times a positive 3x squared plus, so we're bringing down this plus sign, plus we have a negative 2 times a positive 5x plus we have a negative 2 times 1. So we just use the distributive property. And so now we multiply. So our next step is to multiply. Okay, so we're going to have negative 2 times a positive 3 because we can multiply the whole numbers. So we get a negative 6. Do we have any x's we need to multiply? The only thing we have is our x squared here. So now we have negative 6x squared. Plus negative 2 times a positive 5 gives us a negative 10. And then we just have that 1x. And plus a negative 2 times a positive 1 is a negative 2. And so now we need to see if we can add. If we can't add, we need to simplify it further so that we don't have our parentheses. So I see an x squared, I see an x, and then I see a constant. Can we add any of those together? Well, this doesn't have any x's, so I don't have to worry about that. But these two, this is an x squared and that's an x. Are those the same thing? The answer should be a no because this has an exponent of 2 and technically this has an exponent of 1. So our answer is going to be negative 6x squared, and instead of adding the opposite, I'm going to say minus 10x, and instead of saying adding the opposite, I'm going to say minus 2 because technically we can just say, oh, well, this is a positive 1 times a negative 10 to just get a negative 10x. All right, so this is going to be our answer. And on the next page, I really want you to try these problems that I'm going to put down. So this is your try. I want you to attempt these problems. So try these problems. At least get them set up. Try and get the answer as far as you can. The idea is that you're simplifying. So these are 1 and 2 you're going to solve. And then the rest of these you are going to simplify. So you're going to use the distributive property. And then you're going to simplify. Okay, so try that. Pause the video. So number one, we had 20 times 30 plus 1. So when we distributed that, that's going to equal 20 times 30 plus 20 times 1. All right, so we get 20 times 30 plus 20 times 1. 20 times 30 gives us, well, 2 times 3 gives us 6. Then we have 2 zeros after that, plus 20, because 20 times 1 is 20. And then we get 600 plus 20 gets us 620. So notice how you could easily probably do something like this in your head if you tried it. So next, let's do number 2. Number 2 is 12 times the quantity 4 and 1/2, which we can rewrite as 12 times 4 plus 1/2. So now we can distribute this. and we get 12 times 4. So 12 times 4, well, 12 times 2. So if you have to, well, 12 times 2 gets me 24. So then 24 plus 24 gives me 48. So we get 48 plus, I guess I should rewrite it as multiplication first. So that means that we should do 12 times 4 plus 12 times 1/2. And so we get 48 plus 12 times 1/2. Well, what's one? The way to think about this one is, what is 1/2 of 12? Well, half of 12 is just multiplication. You can think of, well, if I cut that in half, I get 6. Or you can look at it like 12 over 6, right? Or not 12 over 6, 12 over 2, okay? So now we get 48 plus 6. Well, 6 plus 8 is 8, 9, 10, 11, 12, 13, 14. So we get 54. And that should be your answer. Okay. So these two are ways to work with problems that you may not be able to answer on your own without a calculator, but you totally can if you know the distributive property. So that's what's really cool about the distributive property. We can do something like that. We have 5 times the quantity, 4x minus 9. So in this example, or in this try problem, I really wanted you to watch out for this negative sign we have. I always suggest rewriting this, or at least thinking about it, like 5 times the quantity, 4x, plus a negative 9. Okay? So instead of parentheses, we'll have brackets, but that's okay. The idea is that we need to be careful about this negative sign, or the subtraction sign. So the way to think about this is we're going to have 5 times 4x and then 5 times a negative 9. This will make a big difference if, say, you have a negative number in front. So we have 5 times 4x plus, because we always bring down our plus sign, positive 5 times a negative 9. So right now, it technically doesn't matter that we have a negative sign there, but it will matter if we have a negative number in front that we're distributing. So now we just did the distributive property, and we are going to do our multiplication next. Okay, we're going to do our multiplication. So 5 times 4 is 20. We don't have an x on the 5, so we just keep the x here. Plus, and 5 times a negative 9 is a negative 40. And now we simplify. Technically, we should add if we can, but we can't add here. So we're just going to make it look prettier. So we're going to have 20x minus 40. So you probably already had that. You didn't have to do this extra step. But the idea is, if I had a negative number, so here's what's going to happen if you have a negative number in front. So say I had a negative 9 or a negative 5. If I had a negative 5, then here I would have a negative 5. Here I would have a negative 5. And so what would then happen is I would look at this, I'd say, okay, well, this is a negative 20, and then this would make this a positive 40, and now I'm going to add those together. If you kept it like this, then you would have negative 5 times 4x minus 9. You would then probably do, okay, negative 5 times 4x, and then minus time, and then have our negative 5 times a positive 9. And so then we would end up with negative 20x, and then minus negative 40. And so, yes, we're going to get the same thing, but a lot of students, we should never have a negative, subtract a negative, okay? Do not do this. No subtract a negatives. No. Subtracting negatives, okay? Do not have subtracting negatives. So we could simplify. We know this is technically a negative 1 times a positive 40 to get a, or a negative 40 to get a positive 40. So this would be your answer for this problem. So just be careful when you're working with that. That's my emphasis. Just be careful when you are working with that. All right, so let's do this next example. So number 4, we had 12 times the quantity, 6 minus 1/2 x, and now we're going to do our distributive property. So we should do 12 times 6 minus 12 times 1/2 x. And so we get 12 times 6 is 40. Let's see. 12 times 6. 6 times 2 is 12. 6 times 1 is 6 plus 1 is 72. Minus, and then we have 12 times 1/2, which we already saw earlier was 6, and we keep that x, and it just so happens that this is our answer. The only issue is proper formatting of problems would be a negative 6x plus 72, because what's happening is we technically have 72 plus a negative 6x, right? And we always want our x terms in front with our constants in the back. So don't worry too much about that now. As you move on, that's going to be a requirement. So we know addition is commutative, so that's why we can basically flip-flop their order. Okay, let's look at number 5. Okay, number 5. We have 1/4 times 16x minus 12y plus 4z. And so now we're going to distribute. We're going to distribute that 1/4. So we get 1/4 times 16x minus 1/4 times 12y plus 1/4 times 4z. And again, I'm not a fan of keeping the negative here, but I would rather have you do plus or add the opposite. So add the opposite, okay? That is my preference, and it will make sense if you start making a ton of mistakes, okay? So now, what's 1/4 of 16? It's 4, so we get 4x, plus 1/4 of 12 is 3, so we get 3y. Oh, but be careful, it's a negative on there. Plus 1/4 of 4 is 1, so we get 1z. Remember I said invisible math, so technically since we're going the other way, we don't need that 1, so we can rewrite this for x. Instead of add the opposite, we have subtract 3y plus z. So this is how I would expect you to write it. Notice how our variables are in alphabetical order. Okay, next problem, number 6. So number 6, we have a negative 2 out front times the quantity 2x squared plus 3x plus 1. And what do we get? We're going to take our term on the outside and we're distributing it to each term on the inside of our parentheses. So we have a negative 2 times 2x squared plus negative 2 times 3x plus a negative 2 times 1. And we end up with negative 2 times 2 to get negative 4x squared plus a negative 2 times a positive 6 to get a negative 6x plus a negative 2 times 1 to get a negative 2. And we are going to simplify this so it looks prettier. So we have negative 4x squared minus 6x minus 2. Okay, and this is the correct format because we always want to put the largest exponent first. So a couple rules. So we want alphabetical. We want largest exponent first. And then we should always have the constant last. Okay, so these are the rules for formatting equations. All right, and we'll talk about that some more as we move on. All right, so the idea with this part of the notes, we're going to talk about what's called a term, which we also call a monomial. And this is going to be a number, a variable, or a product or quotient, because remember, multiplication and division are related. So quotient of numbers and variables. So a couple examples would be like, so something lets a number, so 3, we could also do 10, different numbers, we could do variables, x, y. We could also do different variations of that, so 3x, that's a term. In a monomial, we could do x over 3, we could do zy, we could also do x over z. So all of those are terms, all of those are monomials. The only time when you have not a term is when if a number or a variable or a product is I guess a non-math term broken up by an addition or subtraction sign. So the idea is if I had 3 plus x, this is not. So not a term is this whole thing right here. What is a term is going to be what's inside the 3 and the x. We say those are terms, right? But the whole thing is not a term. Okay? So a monomial or a term is just a number, just a variable, or some combination of those with multiplication or division. Okay? So now let's look at a little bit more. So if we're talking about like terms, so remember like terms have the same variable or the same variable and exponent. So the idea of like terms. If we had 3x plus 2x, we know these are like terms. They have the same variable. They both have x. So we can add them and get 5x. If we had 3x plus 2y, they're different variables. We cannot add them together because they have different variables. So those are not like terms. So like terms, not like terms. Another example would be if we had 3x squared plus 4x squared. These are like terms because they both have x squared. So we have 3x squared plus 4x squared. That tells us we have 3x squareds plus 4x squareds. So we have a total of 7x squareds. So those are like terms. A non-example would be if we had 3x squared plus 4x. So this tells us we have 3 of the x squareds. So we have x squared plus x squared plus x squared. This one tells us we have 4 x's. So that tells us we're adding 4 x's together. Can we combine an x squared and an x? No. Think of this like a 2D shape, and this is like a 1D shape. Are those the same thing? No. So it is already simplified. And we can say that these up here were not simplified, so we had to simplify them for an answer. Okay. All right. So next we're going to talk about simplest form. So I already kind of talked about it. So simplest form this should be familiar. We're looking at the idea of when an expression is replaced by an equivalent expression with no like terms or parentheses. Okay, so it's the idea that we're eliminating our parentheses or any repeating terms. Okay, so we're eliminating our repeating terms and our parentheses. So here's some examples. All right, if we have 4 times the quantity a squared plus 3ab minus ab, we're going to simplify. So those are our directions, simplify. So we're going to simplify this. The first thing we want to do is distribute because we want to get rid of those parentheses. So we're going to have 4a squared plus 4 times 3ab, and then we have our minus ab. So the way to think about this is I just did the distributive property. And now I'm actually going to, so we're going to multiply. And so we get 4a squared plus 12ab minus ab. But remember, we have something called the multiplicative identity. Multiplicative identity. So what that means is if I have ab, that's technically 1ab because I have something, I have the 1 in the front. So that's our invisible math, okay? So that tells us that we technically have 4a squared plus 12ab minus 1ab. And so now we're going to actually use the distributive property again. And we're going to work backwards. So instead of distributing, we're going to basically take out an ab. So we can rewrite this as 4a squared plus, and then we have 12 minus 1, and we had ab. That's the common factor between these two terms right here, okay? So then I was able to pull those out. So if I were to take those out, what's going to happen is I get my ab on the outside, and then I'm left with my 12 minus 1. If I were to distribute this back, I should get this what I started out with. So now we know we have a squared plus 12 minus 1, which is 11ab. The other way to think about this, you don't have to do the distributive property. You could just say, well, these are like terms. And so now I can do 12ab minus 1ab. I could just rewrite it with parentheses and use the associative property and associate these two together. But don't forget to include your plus sign in front. So now we're going to look at this. Can we simplify this any further? No, we can't. Problem. So you're going to try the following. You're going to simplify. All right, so go ahead, pause the video, and try these out. Now that you've tried those problems, let's talk about them. So let's look at number 1. Number 1 was 12. 12, if it'll cooperate. All right, number 1 was 12a minus a. That's the same thing as 12a minus 1a. So we can look at this as 12 minus 1a, which is the same thing as 11a. So that was number 1. Number 2, we had 3x squared plus 2x squared. We have like terms here. So that tells us that we can add these together. So we end up with 6x squared. So we keep our like terms and we add our coefficients, the number that's in front. All right, number 3. Number 3, we have negative 6x plus 3x squared plus 10x squared. Okay, our like terms. So I'm going to use a highlighter this time. to talk about our like terms. So it looks like we have an x squared here, we have an x squared here. So that means I can take those two terms and I can actually add them together first. So what we're going to end up with is we keep our negative 6x in the front. We have a positive 3x squared plus 10x squared. So we're going to have a positive 13x squared. Okay, and we're going to rewrite this so that it's proper form. So we're going to have 13x squared minus 6x. So that is going to be our answer. Okay. So proper form. Again, I'm going to emphasize this. So proper form for equations. So equation, not equations, expressions. That's the word I want. So expressions. So expressions, proper form. You're going to have highest exponent in front. But before you do that, you're going to want to have it in alphabetical order. And we always have constants last. Okay, so there's no constants here, so we don't have to worry about that. We only have x's, so I put my highest exponent of my x first. So another example here would be, say I had x squared plus y squared. What you would do is go in alphabetical order, so x, y, so you'd have x squared plus y squared plus y. And then if you say you had z plus z cubed, you would say z cubed plus z. Okay, we'll talk about that more. I'll keep emphasizing it. Let's look at number 4. Okay, number 4. We had 2p plus 1/2 q. So no like terms, which means it's already simplified. Okay, that was a trick one. All right, let's look at number 5. Okay, we have 4x plus 1/4 times the quantity, 16x minus 20y. All right, so first thing we need to do, order of operations, let's think about this. We're going to distribute because we're trying to simplify. So first thing we want to do is get rid of these parentheses. So think of this as our first step, get rid of our grouping symbols. And we'll talk about this more as we get into more complicated problems, but the idea is we're getting rid of our grouping symbols first. So our first step is always to distribute. You already use the distributive property. So we can bring down our 4x plus, now we have 1/4 times 16x minus 1/4 times 20y. Okay, so we simplify, we get 4x, 1/4 of 16 gives me 4x, minus 1/4 of 20 is 5y. Now we can combine like terms. So that's our second step. We're going to combine like terms. So we get 4x plus 4x is 8x minus 5y. Are those in alphabetical order? X, Y, Z? Yes, they are. So we are done.